Hello, hello, it's Professor Burns here, and I wanted to go ahead and do a video. It might end up being a couple of videos. Remember, I can't go over 15 minutes when I record these on the software I'm using, so I may break them up into a few different videos. But I do want to go over a couple videos going over some important problems for the test number 2 that is due on Saturday at midnight. So I highly recommend you go through these with me, work the problems with me, and make sure you understand them, and email me if you don't understand how I'm getting something. Really be proactive. So if you're struggling, please reach out. The material is getting a little bit harder as we go through the course, and I think this test is going to be a little bit more challenging than the last one. So make sure you feel good about this information. The test will cover chapters 5, 6, and 7. And in the review and info part of the module for this week, there is a list of objectives. There is a review sheet that's pretty good, and I'm going to pull some problems from there to work with you. There's also something here I wrote called Extra Chapter 6 Practice, or Chapter Extra 6. I don't know where I got that title from. But really, this is not just Chapter 6. There's a little Chapter 5 material as well, but it's good information mostly on probability. So I wanted to just point out from this review, I'm not going to spend a lot of time going over it, but there are some really nice questions here that will help you get ready for the test. It talks about z-scores. Make sure you draw a picture for each one of these. I'll go over a couple of these in the other review that are similar. It also talks about probability using the chart. There will be a question on the test where there's a chart, and then we'll ask you to calculate some different probabilities. And then there is also a couple questions. There's a couple questions on here about, let me think. I'm trying to think what, this number 16 I'm looking at, 16 you can skip. That one we did not cover this semester. But 15 is a good one and 14 is a good one. So make sure you take a look at those. I did also notice there's some regression questions on here. Those will not be on this test, but they will be on the final exam. So those wouldn't be bad to look at later on. And then I think I put the answers for these. Yeah, the answers are right here. So make sure you take a look at the answers as you go through those. Those are all good questions to look over for the test. But for now, I'm going to go ahead and look at this one that says chapters 5 through 7 review, and I've got a PDF version of it to use with my tablet software. And I've circled a few questions. Here's what it looks like. I've circled a few questions here that I think are probably worth our time to take a look at. So I'm going to go through, I'm going to start with question number 3 here. And let me see if I can zoom in. Here we go. Question number 3 here. It talks about, it says, a Pew poll said that 93% of young adults in the United States have internet access. Assuming that this is still correct, if 2 young adults in the United States are randomly selected, then what is the probability that they both have internet access? So you want to think of this kind of like almost like an and question. It's like the probability that the first person has internet, I'll use I for internet, and the second person has internet. And if it's a random selection, if we're randomly selecting from the population, that means we can assume that they are independent. They have no effect on each other. They don't live in the same household. They don't know each other, whatever. Then we can multiply when we have an and question. So that's the probability of the first times the probability of the second. So the probability that they both have internet access, I'm going to multiply those together. So I'm going to do 0.93, and you have to make that 93% a decimal, times 0.93, and then I'm going to put that in the calculator, and that should get me my answer. Let's see what that actually gives us, 0.8649. So about an 87%, roughly 86.5% chance that both of them would have internet access. Now, B says, if one young adult in the United States was randomly selected, what is the probability that he or she does not have internet access? So just one adult. So the not would be the complement. The complement would be the probability if somebody does have internet. The complement would be the probability that somebody does not have internet. So the probability that they do not have internet, I think we used a little C notation there for the complement, would be 1 minus the probability that they do have internet access, which means it would be 0.07 or about a 7% chance. All right, let's take a look at question number 4. We've got a random sample of 1,275 people, and we asked, is college worth a financial investment? And we asked them to classify themselves as either male or female, and they had the option of saying either no, yes, or unsure. Those were the only choices they could answer. So here's the responses. Here are the numbers. Notice that 1,275 is the total. So this is called a two-way table. And so when you see a two-way table like this, whatever's in the column here at the end and the row going at the bottom like this, those should total up to be the same thing. And in this case, that's 1,275. That's the entire sample. Make sure you know what the term mutually exclusive means. And on this test, just like the last one, you can still use an index card. So if you're afraid there's a term you might forget, this might be one to jot down on the index card. Mutually exclusive, I like to think of as there is no overlap. The two groups cannot happen at the same time. So they cannot occur or happen together or at the same time. So I'm not even looking at the choices yet, but in this sample, the thing that probably jumps out at me first would be female and male. You're either one or the other for the purposes of this survey. They had to choose either a female or a male. You're either a Democrat or a Republican. You have to choose one. You can't, when you go to register, you can't be both. You have to pick one or the other. Those would be examples of things that are mutually exclusive. So I'm looking at the choices here, the responses of no and female. I would say those are not mutually exclusive because there's overlap. There is a group that is both no and female. That's this group right here, the 45 people. So that's not it. Yes and male. Well, is there a group that has overlap? Yes and male. That's this group right here. So those are not mutually exclusive. The responses of yes and no. Well, think about it. Could somebody have responded both yes and no on the survey? The answer is no. They could have said unsure. That's different. I'm talking about yes and no. So this row and this row. One way to figure it out looking at a table like this is either they're both responses are in rows or both in columns. That's another way to think about it. This would have been the one that's mutually exclusive. There is no overlap between the yes and the no group. All right, B says, what is the probability that the person chosen said yes? So just from the entire sample, what is the probability somebody said yes? Remember, when you do these, you're going to do the denominator is going to be the total for whatever sample you're looking at, for whatever question they're asking you about, whatever probability, and then the numerator is whatever group they're interested in. In this case, it'll be the yes. So of the entire group of 1,275, we had, it looks like 978 who said yes. So that's going to be the probability there. I'm going to skip the changing it to a decimal, but make sure you know how to do that in your calculator. You do 978 divided by 1,275. And then to make it a percentage, remember, move the decimal 2 spaces to the right. C says, what is the probability that the person chosen said no or is a female? So when you see the word or, this is where you want to consider whether or not they are mutually exclusive. In other words, ask yourself, is there overlap? So in this case, the probability that somebody said no or female, it would be the probability that somebody said no plus the probability that somebody said female minus the probability that somebody said no and is a female. Make sure you know that little formula for or probabilities. That's important. So in this case, these events are not mutually exclusive. There is going to be overlap of a group that is both no and female. So that has to be subtracted. Otherwise, you're going to double count that group. So let's look at the chart. The people who said no would be this row right here. So it would be 101 out of the 1,275 total. Plus female, that would be this column right here. So that would be 722 out of 1,275. minus, and notice there is overlap. That's this group right here, the no and female. That's the 45. See, the problem is if you don't subtract that overlapping group, you're going to end up double counting those 45 people. And that's where you're going to run into an issue. So you have to remember to consider overlap when you're counting, when you're doing an OR probability on these chart questions. So what you want to do is you want to just work with the numerators here to get your final total. So I'm going to do 101 plus 722, and then I'm going to subtract 45, and I'm getting 778 out of the common denominator 1275. And that's what you're going to put in your calculator to get your decimal. Let's look at part D. D says, what is the probability that the person chosen said unsure and is a male? So and means you want the overlap group. You want the group that is in both categories. Nothing to add. If it's an and question and they don't give you a chart, like that last question we had where we were talking about internet access, that's like an and question. You multiply. But when you're given the chart, you can just go straight to the group that's in both categories. So the probability that somebody is unsure and male would be the unsure and male. I'm going to go straight to that group in the chart that's in the overlap. And let me make some space here. Males who were also unsure would just be this little group right here, unsure and male. So it would be 96 out of the 1275. And then the last question says, what is the probability that the person chosen said yes, given that the person is female? So when you see the word given that, that's the clue that you're using what's called conditional probability. Conditional probability means on the condition that somebody is a female. We only are interested in the second group after the word given that or after that little line symbol. In this case, that's the female. And what that tells you is that you're interested in, that changes your sample size. So instead of looking at the entire 1275, now I'm only looking at the females. So exclusively from the female group. So the females, there are 722, and they wanted, of those 722, the probability that somebody said yes. Well, from that 722, there are 577 who said yes. So that would be probability that somebody said yes, given that they are female, would be 577. Is that what it was? I forgot what the number was. Yeah, 577 out of 722. So that's your conditional probability. Last little thing I'm going to talk about in this video, and then I'm going to go on to the next video, is make sure you know the difference between discrete and continuous variables. Discrete are the variables that you can count. Things like if it says number of people in a classroom, number of computers in an office, number of I don't know, keys on a keyboard, number of sodas in a vending machine. Those would be discrete. 1, 2, 3, 4, 5. Continuous, on the other hand, are variables that you measure. The difference with continuous variables, and continuous are like functions in an algebra class. They would cover a range of numbers, from 0 all the way up to 100 and anything in between. I can't individually list. Those would be things that you would measure. Amount of rainfall. Let me think. Heights. Weights. Time. Time would be a continuous variable because it could be anything from seconds, milliseconds, and I could break it down. There's no way to count time. We measure time. Ask yourself, do I count it or do I measure it? If it's something we count, then it's a discrete variable. If it's something we measure, it's going to be a continuous variable. So make sure you're clear on the difference between those two types of variables. When it's a continuous variable, the way we represent it is to use this probability density function, or we use a graph as we do like in number 5. This is a uniform distribution, but it's a continuous variable because you're talking about weights. the weights of a package in number 5 can be anywhere between 14 and 20 pounds, for example. If it's a discrete variable, we would list the probabilities for it in a chart, for example, like heads or tails, flipping a coin, things like that. So I'm going to pause here and I'm going to go to the next video, and then I'm going to look at question number 5 with you.